Good morning. The purpose of this video is to use Le Chatelier's principle to explain how equilibriums adjust to disturbances and to show that the equilibrium constant stays the same if you adjust concentrations, but the equilibrium constant will change its value if you adjust temperature. So we have a simple reaction of B being converted to A. We're making that reaction an exothermic reaction. So if we write the equilibrium constant for that reaction, it will be the concentration of the products over the concentration of the reactants. And at the temperature we're starting with, we're making that value a half. So to start my demonstration, I'm going to place out 12 B cards. 4, 8, 12, and we're going to create equilibrium. So given time, we'll get to the 2-to-1 ratio, twice as many B's as A's. So over time, 4 B's will convert to A's, and we now have an equilibrium mix at that temperature, twice as many B's to A's. Now, that's happily at equilibrium, which means it's not a static situation. It means for every B that goes to an A is going to a B, etc. So, Le Chatelier principle says if we disturb that equilibrium in any way, then the system will respond to counteract the change. So my disturbance here will be to add 3 B's. So looking at our equation, if we add more B's, we'd expect the reaction to go to the right to convert some of those extra B's into A's to get back to equilibrium again, which is what we're predicting here. We've upped our B's by 3. We're expecting the number of B's to go down, and to do that, I think we just need to convert 1 for us to arrive back at the 2-to-1 ratio. So equilibrium has been established after we've added more B's, and our equilibrium constant has stayed the same, 2-to-1.5. Now, if I disturb temperature, let's say I increase temperature, Le Chatelier will predict that the reaction will go to the left to use up some of the extra heat added. That means some A's are going to go to B's. So some A's will convert to B's, and if that's the case, then our 2-to-1 ratio is totally gone, and hence we have a new equilibrium constant. Let's say that at our new temperature, which is higher, the equilibrium constant then becomes a quarter. So that tells us how many A's we'll have to convert. So again, Le Chatelier is saying increasing temperature, the reaction will go to the left to remove some of the extra heat added, and that means that A's are converted to B's. The A's that converted, well, we're going to need to have a 1-to-4 ratio, 4 times as many B's as A's. And if we just reorganise these a little differently, that'll be easier to show how many we need to convert. So we can see would it just be 1 A needs to go to a B to arrive at our new equilibrium mix at this new temperature, where the equilibrium constant is 1-to-4. So just to summarise, Le Chatelier's principle works for explaining concentration, pressure, volume, temperature changes, but the consequences for the equilibrium constant are different whether we are changing concentrations or temperature. Temperature will give us a new equilibrium constant. Thank you for watching.